All right, let's dive right in. Today, we are pulling back the curtain on something called SAST, or Static Application Security Testing. And look, if you write code, manage code, or rely on software in any way, this is for you. It's your first and maybe your most important line of defense. So to really get this, I want you to think about a question. What is the actual cost of one single bad line of code? I know, it sounds tiny, right? But that one little mistake can spiral into a massive data breach, a catastrophic system failure. We're talking huge financial hits and a reputation that's just shattered. The stakes are incredibly high.
And this chart, it says it all. The longer a security bug hides in your code, the more expensive and painful it is to fix. I mean, look at that difference. Catching it while you're still developing, that's a tiny blip, an easy fix. But finding that same bug when it's live, out in production, that's not a blip. That's a 5-alarm fire.
And here's the kicker. This problem is getting way harder to solve. Modern apps aren't just one big block of code anymore. They're these sprawling, complex webs of microservices, tons of open-source packages, automated pipelines, cloud infrastructure, you name it. And every single one of those pieces adds another door or window for an attacker to try and get through.
So, faced with all this risk and all this complexity, how in the world do you get ahead of it? How do you find those little ticking time bombs before they go off? Well, that's where SAST comes in.
So what is it? SAST is a way of scanning an application's source code to find security vulnerabilities. And here is the absolute key. It does this without ever running the code. Just imagine having a security expert who can read your code at the speed of light. That's basically what SAST is.
You know, probably the best way to think about it is this. SAST is like a spell checker, but for security. As you're writing your code, it's right there with you, looking over your shoulder and flagging potential security mistakes in real time. It catches them long before they ever have a chance to become a real problem.
So what's this security spell checker actually looking for? Oh, all the usual suspects. Big, scary stuff like SQL injection, but also just common, everyday coding mistakes and weird bits of logic that could be abused. And it is especially good at finding one of the most dangerous and most common mistakes out there: hard-coded secrets. You know, passwords and API keys just sitting there in plain text.
Okay, so we know what SAST is, but how does it actually fit into a developer's day-to-day life? Because if it's a pain to use, nobody's going to use it, right?
Well, the beauty of it is that the whole process is smooth and automated. A developer writes some code, the SAST tool scans it, either as they're typing or maybe when they commit their changes. The tool looks for risky patterns, flags anything that looks fishy. It'll even tell you how severe it thinks the issue is, and often it'll suggest how to fix it. The developer makes the fix, and the cycle just keeps going. It's like having an automated security code review running 24/7. And this is where SAST really shines. It's not some separate, clunky thing you have to remember to do. It integrates right into the tools developers already use every single day. We're talking right inside their code editor, as part of their pull requests, baked into their CI/CD pipelines. It meets them exactly where they are, which is why it's so effective.
And this whole idea, this process, it's the very heart of what we in the industry call shifting left. It just means we're moving security from the very end of the process to the very beginning. You're not trying to bolt on security at the last minute, you're building it in from line one.
Okay, that's the theory. It sounds great, but let's get real. What kind of simple, everyday mistakes does a SAST tool actually catch in the wild? Let's look at a few absolute classics.
First up, a Hall of Famer, SQL injection. A SAST tool would see this line of code and just scream. Why? Because you're taking raw input from a user and just jamming it straight into a database query. That's like leaving your front door wide open with a sign that says, "Come on in." It's incredibly dangerous, and a SAST tool spots this from a mile away. And here's another one you see all the time: hard-coded secrets. A developer just slaps an API key or a password right into the code. This is a ticking time bomb. The moment this code gets into a public repository, that secret is out there for the whole world to see. SAST is built to find these before that ever happens.
See, SAST doesn't just find obvious mistakes, it also nudges developers toward best practices. Using a really old and weak hashing algorithm like MD5 for passwords, that's a huge no-no these days. A good SAST tool will flag this right away and say, hey, you should probably use something much stronger, like Argon 2 or bcrypt.
Now, it's super important to get this next part. SAST is a powerhouse, for sure, but it's just one piece of the security puzzle. A lot of people get confused about how it's different from other tools like DAST and SCA, so let's just clear the air right now.
This table breaks it down perfectly. SAST, like we said, scans the raw source code. It's a white box approach. DAST, on the other hand, is black box. It attacks your application while it's actually running, trying to find holes from the outside, things you'd only see in a live environment. And then you've got SCA, which does something totally different. It just looks at all the open source libraries you're using and checks if any of them have known security problems.
So you see, they're not fighting for the same job. They're on the same team. SAST finds flaws in your own code. DAST finds flaws in how that code behaves when it's running. And SCA finds flaws in code you didn't even write. For a truly solid security setup, you absolutely need all three working together.
Okay, let's bring it all home. When you do this right, when you really embrace SAST, what's the ultimate payoff? What's the big picture goal we're all aiming for here? Well, the benefits are just massive. You find those vulnerabilities early, which saves a ton of time, money, and stress. You're creating an automated gatekeeper that literally stops insecure code from ever getting into your main codebase. And maybe most importantly, you're helping your developers learn. It's a feedback loop that teaches them to write better, more secure code from the start. It's a total win-win.
So, if you only remember one thing from this whole explainer, let it be this. SAST is so much more than just a bug-finding tool. It's about changing your culture. It's about building software that is secure by design, not just by accident.
And that really leaves us with one final question to think about. When your developers finish their work, is their code just getting a code complete stamp, or is it getting a real security checkup? Because in the world we live in today, that small distinction makes all the difference.